All right. I'd like to welcome everybody to the May meeting of the Homebrew Robotics Club. We start off the meeting with robot news. Let me share my screen here. Actually, let me set it so that, okay, everybody can share their screen. That's cool. And we've got a new version of ROS 2, Galactic Geocolony. I think I said that right. That looks like it's good for a year and a half. Foxy Fitzroy's still going to 2023. And I think we're ramping up to 5-year long-term releases. So we'll get there. And Geocolony is a turtle like this.
Oh.
Isn't that beautiful?
Whoa. Cool.
Why is the end of life date for G earlier than for F?
Because you alternate between short-term and long-term releases. And even as they ramp up to it, you'll get into 5-year. And Foxy Fitzroy is still relatively early, so it's only 3-year.
Is it similar to like Ubuntu's release schedule?
Yeah,
Similar.
exactly. Yeah, and that's that. Well, historically, ROS has actually tracked that. They would pair a ROS release with a Ubuntu release, and follow the same long-term support schedule.
So the Geocolony is really pretty. That's a pretty turtle. Is there any more robot news out there? Robot news, going once, going twice. All right.
Camp, I got maybe.
Ross with 2 S's has his hands up. What's going on, Ross?
Oh, just nice to be with the gang again. Not that I'm a NVIDIA promoter or anything, but I attended one of the sessions that was describing the fun things you can do with your Jetson Nano at the GTC 21 a month or so ago. And I got a letter in the mail last week that said I won a t-shirt. And so here is the lousy t-shirt that I got.
Let's have a better look at that. Show us that t-shirt again, Ross.
There we go.
Wow, that's better than a poke an eye with a sharp stick. Yeah.
I signed up for that thing. Where's my free jetbot? I thought they were going to give away
that's right.
jetbot.
Well, it turns out I guess I got other news too. I do own a. See, how do you do this? I actually do own a jetbot, but along with the T-shirt, I got a new dev kit. So now, of course, I already have one.
Okay.
Anyway, that was cool. So as far as I show the JetBot on purpose because my real news is, see, if I share a screen, I ran across this. This is a very exciting GitHub, but what's cool about it is that this person posted the code, the scripts and the codes to turn your JetBot into a ROS 2 bot. And in this case, and he would, because of the additional power that gives him, he added the Intel cameras, and it works by the ROS 2. ROS 2 works on the Jetson Nano using the Docker. And so I've corresponded with the gentleman a bit. And now I know more about Dockers than I did before I did. But this really does look like an interesting way of running Foxy and learning about Foxy, learning about Dockers on a relatively simple but powerful device like this.
Hey Ross, any news on when NVIDIA, if ever, is going to have Ubuntu 20.04 working on them?
They're not. There was a press release that just came out. Where's my stop share? That they're going to continue adding to Jetpack 4 up to 4.6 over the next year, and then about a year and a half from now stop. And with the what's it called, the core 4 point something or other, below 5 for the period that the Jetpack is 4 point something or other, until they release a new version of the Jetson Nano in 2023. I think I saw the date. So in other words, they aren't.
So you're saying,
Ross, do you think you could put the link to that GitHub up?
the current?
Yeah.
Nano
Oh, the one
will
that I
never
just
be
showed
able
you.
to run
Yeah, absolutely.
Ubuntu 20.
Sure. And anyway, this what I've just the narrative I just gave was hidden away on, on their new news thing. They have a continuous stream of that. Maybe I'll try and find it and I could post that too. It actually gives their roadmap for the next several years that includes what I just said, that it's a mention of the successor to the Jetson Nano.
Very cool. Any more robot news?
I do.
I get that straight. The Jetson Nano will never be able to be updated to Ubuntu 20.
Correct.
Well,
They
this
have
version, yeah.
their answer to that in the several posts that they made
Hardware.
is use a Docker. And I've actually loaded a Docker onto my Jetson Nano. It's actually pretty damn good. I'm pretty impressed by just as an entry level kind of thing, but it actually does work. That's as far as it'll go.
Oh, sorry.
It's their hardware GPU that is not compatible. All right, moving on. Next hardware.
I went to the first in-person DIY Robocars at Circuit Launch last week, and they had like a special guest. Let's see if I can share that. Share screen. This is on my phone, so see how that goes. So they Circuit Launch just got a Boston Dynamics Spot, and the cool part is it's not just like they've got one, but you can actually one of the companies is like trying to give access to people who don't have $1 million access to build on this platform. And so I signed up for their service, and it's kind of like a little bit for people who are already developing within the Circuit Launch. Circuit Launch, for people who don't know, is a Oakland-based incubator startup, sort of incubator / makerspace for hardware companies, and they've got a really great network, and I recommend their class. I'm not being paid to say that, but yeah. I think what's cool about this is just to getting to see Spot in person, and also Robocars is coming back in like. There's actually people there, and there's like 100 people. It was super fun. So there's my Robo news.
Yeah, there was a post on the mailing list, I believe, that showed the robo cars. I would call them donkey cars driving around. They were doing really well.
Yeah, I was there, and
some of them. But the donkeys themselves, not so much.
I don't think any of the donkeys actually made it around the full track.
What cars was it that were going around the track? Looked like they were actually racing.
Yeah, they use a different software stack. So
What do you call those?
I don't know if they have a class, but there was one of them that like he had a custom software stack in order to do that. The other one, I'm not.
Oh, this was deep learning.
Yeah.
This was
yeah.
Those Amazon deep learning cars, I think.
No, no, they didn't do well either.
Yeah.
So Andy was always in the front even before the pandemic, and he is still very good. But he is using his own setup, his own camera setup, everything. So that doesn't really translate well into other cars.
Who was that?
Andrew Sloan is his name, I believe.
Ah, isn't Andy the guy that originally did Donkey Car?
No.
I thought so.
He was basically always there from the beginning, but
Any more robot news this evening? Hey, here it is. Okay. Let me, let's see here. Bear with me.
If that's that yelling might actually be me. Oh yeah, that is me. Hey Camp, can you go back?
Yes, what? What were you asking, Oren? What were you saying?
You're muted, Oren.
Anyways, I think we're moving along. Any more robot news? I'll post that link. Well,
also posted a link of a video with Spot doing part of the course too.
Yeah, that video is on LinkedIn. I don't actually have a link for it. Anyways, okay. Any more robot news? Okay, moving along. Let's get into club news now. So this is May. June is another challenge month. This is our 19th annual HBRC challenge. This will be phase 2. And so as everybody knows, challenge meetings are all show and tell meetings, and I will be bugging you all month long to build and have something to show for the challenge meeting. We are a builders club. This is not the Talk About Robots club. So you are responsible for the presentation in June, and that'll be June the 30th. So you got plenty of time, 4 weeks. I'm gonna be bugging you all week long, all month long. I'll keep the same subject heading, so if you don't want to hear about it, you don't have to click on it. Don't take it personal. I'm pretty much talking about myself when I make these posts. So you're responsible for the presentation next month. Build something, all right? Any other club news?
Hey, Camp, I just wanted to say the other club that doesn't build things, that's the Home Talk Robot Club. Yeah. Yeah. Well, I know somebody, you probably know him too. Steve Nelson. He was a part of the what do they call themselves? The Builders Club or something, and he got kicked out because nobody ever built anything. He was the only one building, and he was fussing at everybody about not building anything, but he got kicked out of that club. Anyways, All right. Any other club news?
Camp, I will
we-
remind you, at the early days of HPRC, not much building was going on. So
It kind of started with the Bobot, didn't it? That infamous Bobot class.
that helped.
Yeah.
There was
Yeah.
a little before that, but yeah, we weren't building very much at the beginning. So
All right, folks. Let's now that we're building, let's move along here. Mark, are you charging your batteries now? Oh, we got show and tell. I'm sorry. Okay, show and tell time. So you got plenty of time. So let me, if I may, show what I'm working on here. I'm building as everybody knows, I'm writing a book, and one of the chapters is going to be Robo Magellan. And I've got a new Robo Magellan robot here. Can you see that? Let me spotlight. See if I can spotlight my.
No. Camp, I don't think you're sharing yet.
Well, if I'm talking and you've got it on speaker view, you should be able to see that. Can you see that dinosaur?
We can see the static page of you with your tabletop.
Okay, but that's on my computer. I've got let me see, I'm on, oh, there I am. Let's see here, more.
There you go.
And
Spotlighted you, Camp.
okay, thank you, Chris Mayer, ladies and gentlemen. All right, so this is Yoshi, YOSHEE, so I don't get any trouble with Nintendo. And basically, this is going to be Ackerman steering, and I've got let's see, I'm going to be using an Arduino, and I've got a GPS here. The deal is to get to the GPS coordinate. Oh, I've got a what is this called? Somebody recognizes this. This is the it's electronic speed controller. Thank you. And what's the name of this speed controller? I should know that. It's not Razer. It's something.
It's called the Red Speed Controller.
Yes, this is the Red Speed Controller. And I've got this Oak D camera on my steering here. I've chopped off the steering wheel. Oh, I've got this nice huge servo here. This is a 180-degree servo. I'm going to mount that on the steering, okay, and steer the kid's power wheel here, okay. And I've got an Oak D camera there. Let me, if I may, I'll share a link to the servo. Is Mike Wimble out there? Mike Wimble, what speed controller is this? It's a small version.
Oh, the RoboClaw?
Yeah, RoboClaw. Thank you for that. This is the small RoboClaw, small 2-channel 7-amp RoboClaw. And I've got this Oak D camera on it. The Oak D camera is really cool. It's a 3D camera, and it also has AI capabilities. Let me plug it in and give it a quick demo here. Let's see. Chris, remove the spotlight from the camera here. I'm going to share screen. Actually, we could probably have both going. Okay. And so here's the RGB, and this is the depth. And let's see here. See if this thing can spot my cat. Oops. Come here.
It's a bird for a second.
Bird, dog, yes, it's guessing. But see, those are chairs. Come on. Chairs.
it was kind of funny. I was at Mom's house. I was looking at it and pointing it at the walker, and it kept oscillating between chair and bicycle. It was like 75% chair, 25% bicycle. And you can train it for things too. So I'll put this on my, I'll put this on my, the front of this kid's riding toy with this big servo, so it can look back and forth, and I'll use the GPS to drive it to the GPS coordinate, at which point we'll start looking around for the orange cone and drive it into the orange cone. So it'll be a little different. Most of my robots are differential drive, but I'm going to do this one with this this kid's toy, so that'd be fun. What else we got for show and tell out there?
Hey, Cam, can it identify a beer?
You can train it for anything. Yeah. Oh, this is the Oak D from the folks at OpenCV. I'll post a link.
Have you all heard about Teachable Machine from Google?
What's the question?
Have you guys heard of Teachable Machine, the project from Google?
I have heard of that.
I used it in a hackathon I won recently, and it was like a Zoom, scavenger hunt where you put objects in front of the camera, and I thought it was a good kind of the Oak camera you're showing. Like it pops up.
Yeah, did they use YOLO on that? You only look once?
I'm not sure what the underlying part, but I think it's more about it's like some transfer learning thing. You could only have classes. Like the output of it was not location, just there is a 45% one of the classes, so 45% chair in the scene. And the neat part about it is not really that it's super accurate or anything. It's just that the way you train it is all in the browser, so it's like very, very approachable for people who are new to machine learning.
Interesting. Yeah, this one's cool because all of the processing is done in the camera. So, it's just giving you a stream and, telling you what it sees, telling you the depth information. And of course, there's a camera there too, RGB. Who else has something for show and tell this evening? Come on, somebody's got to have something.
I can talk about my master's project.
Shiloh, you're up.
All right. Okay, let me share my screen real quick. I actually whipped up some slides for this. Yeah, this isn't much of a demo, for which I apologize, but hey, it's pretty cool that I made up an algorithm, I think, so. Yeah. What are my notes? Here are my notes. Yeah, so my master's thesis, which I just finished, so now MIT will finally let me leave, is about robot path planning, specifically like path planning across multiple maps. So a lot of you have probably seen path planning with ROS before, right? You go into ARVAs and you click your goal and it gives you a nice little green path and it just goes there. So what happens if you have a multi-floor building or a really big environment that's split into multiple map chunks? So even I'm assuming here that you know how to ride the elevator. And so the big problem here is you want to do your path planning across multiple maps. And now you have an algorithm to do that. So let's say you have this topological graph of your various maps. You have a start position in one map and you have a goal position in another. And these red edges that connect up the various maps are deterministic and perfectly reliable, which is a hilarious assumption, but let's go with it for now. And then the blue edges, which go within the various maps, are the ones that we have to find plans for. And so for every pair of nodes in each floor, I automatically add blue within floor edges. So not all of these may actually turn out to be feasible. It's a fun surprise. And the other big challenge here is that there may turn out to be multiple paths through the topological graph. And ahead of time, we don't know which one is going to turn out to be the best. And this is also something that my algorithm deals with, but nobody wants to look at pseudocode at this time of night. So I'm going to gloss over the technical details and show you the fun results. So essentially, I'm using an underlying path planning algorithm for each map to solve the within floor edges, and then my algorithm determines which edges you try and in what order. Yeah, so one of the first tests I did was actually a performance comparison. Like, if you have a really big 2D map, you could in theory just use like a garden variety path planning algorithm on it, right? But does it give you a performance boost if you split it up into like this graph structure? So my first problem here was actually finding a really big 2D map, because you know, a lot of the public data sets are researchers who just map like one floor of the lab, and they're like, that's fine, right? That's all anyone could ever need. So that's not really enough for me. So I flailed around for a little while. I actually emailed some people at Fetch. But then I was like, hey, MIT has all these like building floor plans that are just online and any MIT student can download them. So I downloaded all of them. And I made a map of all of the contiguous basements and tunnels. So basically everything in the basement that a wheeled robot could get to without going up any stairs. And this is at like a resolution of 25 pixels per meter. So this whole thing is like 12,000 by 8,000 pixels. It's huge. So now I can test if it's faster to use like one map per building or to just edit the whole thing together into this enormous single map. Yeah, so if I use my algorithm to find a path from building 1 on one side of campus to building E19 on the other, it goes through like 10 other buildings and it takes around 8 seconds to find this path, which is not actually too bad. And then with the contiguous map, if I use the exact same planner, it takes on average 900 seconds. And I tried a couple different algorithms for within floor planning, and pretty consistently I get 1 or 2 orders of magnitude of a speed up, which is pretty fun. And then reassuringly, it also works for multi-floor buildings, which was my original use case. So I tried the status center, which if you've not seen it, it's like someone took 3 normal buildings and smashed them together into this horrible monstrosity that has, God, when I was going through this thing's floor plans, I discovered so many elevators that I'd never found before after going to this school for 5 years and spending a lot of my time here in this building, which is where a lot of the robotics classes are. So yeah, so my algorithm surprisingly does eventually figure out how to get through all these elevators, which is something I fail to do a lot of the time. And it can get to this one point on the 7th floor through this elevator bank, across the 3rd floor, through this other elevator bank to this other point on the 9th floor. So that's cool. One hilarious thing about the way I'm modeling elevators is that each elevator bank just gets its own tiny little map, which I'm calling the elevator dimension. So the way you take the elevator is you're magically transported into the elevator dimension, which is just the inside of the elevator floating around in the void. And then you're magically transported to your destination floor, which, as we all know, is definitely how elevators work in real life. Yeah, so unfortunately, this multi-floor planning is a lot slower than this just all basement map that we looked at earlier, which is because about 90% of these really tempting looking within floor edges that go like between these 2 towers aren't actually traversable because there's no way to get between like these 2 halves of the floor. But I have some ideas for efficiency improvements that I may be able to implement at some point. So yeah, they accepted my thesis, so I figure that's good enough for now. If you want to look at my code for some reason, it is up on GitHub, and the thesis is not yet on DSpace, but it will appear at some point if for some reason you really want to slog through 60 pages of technical detail. And that's all I got.
Woo.
So Shiloh,
Congratulations, Shiloh.
Shiloh,
I have
this
a quick
sounds like
question. Shiloh, does A star not work with this?
So A star is really slow. So usually for path planning in this kind of thing, you would use a probabilistic algorithm like RRT star or like PRM star. Lots of RRT star variants actually. I tried RRT star and I tried RRT connect as my underlying algorithm, if anyone's interested.
So you're sacrificing efficiency for CPU time?
So how do you mean, like for the choice of RRT star versus A star? Or?
Because then you won't guarantee the shortest path, right?
Oh, RRT star does asymptotically, if you give it enough time, give you an optimal path. So part of my challenge is like, I want to like have those same like, you know, probabilistic completeness and asymptotic optimality guarantees for my algorithm as like the underlying within floor algorithm has. So like if you let like RRT star run for long enough, your path will asymptotically approach optimality.
Oh, okay.
Yeah, so yeah, the
in
real
mathematics. Hi, in mathematics, isn't this graph theory? Is the area mathematics?
It sort of gets into graph theory. Actually, I was looking at some like weird algorithms for like probabilistic graph cuts and like that kind of thing. I'm not very good at algorithms, but basically like if you randomly cut some number of edges in a graph, like what's the probability that you no longer have a path from one side of the graph to the other, which I never really found a good answer to that question. But I certainly learned some things.
No, the real question is, can it help humans go through the building?
That remains to be seen. Once we all get back on campus, I'll be excited to find out if I actually know how to navigate Stata now, because I would just like have all the Stata floor plans like downloaded to my laptop, so I'd like get lost and then I'd hang out in the stairwell and pull up the floor plans. Yeah, we'll see.
Awesome work. Thanks for sharing. Love it.
Glad you like it.
All right, who else has a show and tell?
Well, I guess I have a super fast one, but it's nothing.
Who's that?
Oh, this is Mark.
Okay, you're doing the presentation.
I know, but am I not allowed to do this?
Go ahead.
Anyway, I saw.
You should have your funny little mustache on or something.
I saw Ms. Davis and inspired me some time back. So I'm dorking around with making an in-move little thingy. I don't know what I'll do with it.
Yay, a fellow.
Yeah.
Very inspiring. You two and your daughter are the masters of in-move.
Well, thank you.
That's it.
Mark, hold that upside. I want to get a snapshot.
Yay.
Beautiful.
Looks great.
All right.
I actually made it 0.8 size because my printer can't handle the full size.
Oh yeah.
So I'm having grief with scaling solenoid things and making my own stuff, but that's okay.
Yeah, it looks like multiple solid pieces. My daughter built the individual small slices, but we went back later on and then built the connected pieces. So it looks really sleek on yours.
Well, it's a fun experiment. Thank you for the inspiration.
Mm-hmm. Who else has a show and tell? Going once, going twice. All right. So this evening we have Mark Johnston presenting Easy Map. He's as good looking as he is smart. Easy is a web map.
Oh, thanks a lot. Thanks a lot, Cam.
You can take that how you want. web app. He's really smart. A web app. This is a web app on top of Llama, a localization and mapping library from the Intelligent Robotics and Systems Laboratory at the University of Aveiro, Portugal. He will demonstrate it on the Magni robot by Ubiquity Robotics. Mark Johnston, ladies and gentlemen.
Woo! You're muted.
Mark, you are
Mark,
still muted.
You're still muted.
Okay, it was hiding. All right, I should be live now. Sorry. Got it?
Yes.
Yeah, okay, cool.
Mark Johnston, ladies and gentlemen.
All right. So anyway, Easy Map is an attempt to kind of make a point and click thing to get people excited about doing stuff, and you can build on top of it or what have you. So it's a graphical sort of thing, as we'll see shortly. And okay. So you basically connect to the access point on the Magni, and then you connect to a well-known port with a Chrome browser or some other browser. And you get a little splash screen. And what we'll see in a moment is you have some tank controls, like forward, back, right, and left type controls, a live video feed, and there you go. And some battery status, and you can take pictures. You can just drive around with this for the heck of it, as you know, messing around. But the fun comes for Easy Map is where you click this on the right hand side, that interesting little icon that's I don't know how my cursor can show up, so I'm afraid I'm a PowerPoint noob, but anyway, to the right, there's a little thing, you click on that, and then you get the screen that still has the controls for nav, for moving around, and the other controls. But now you can start making a map, and it instantly drops into making a map, doing a mapping of the area. And you drive forward and drive back a few times, and you fill out the map, and we'll see that in a moment. And then you get a little area that you can now, okay, here you go. So I put this a little early in the presentation. All right, well, we have a Magni robot. We have a LiDAR with 360 degree, which we're using the N301 LS LiDAR. And it has a front end web app that you've seen a little bit of so far. And then you have this Llama ROS, which we'll talk about later a little bit. And we have this thing called Move Basic, which is a dumbed down move base that's just does very simplistic things. No path planning in that, just avoiding hitting things. And you can record video and record ROS bags and so forth. So the next thing you do is you double click on as many little goals as you'd like to have the robot follow later. So you just double click them, and once you've double clicked them, you can grab them and move them and do some other fun things, which we'll show in the demo. So now you have your path, and you save the route. There's a, by the way, camp, save the map.
Save the map before you kill the mapping algorithm. Tip of the day.
Actually, so the cool thing here is this actually will save the map. But if you want to go back into this later and then pull back the map and set your pose and so forth, in that case, you do have to save the map. So anyway, you can also save the route, which I've defined here. Then for each of these little points, once the goals exist, you can add more goals, you can delete them, you can drag them around. So that's kind of nice, because you start driving, you say, wait a minute, I'm getting a little too close to the fine porcelain you know, cabinet of my wife, and that could mean the end of my life. So you move things around, and you can define actions. So you have a way of going over a goal and defining an action, like stop here for 3 seconds, or change the speed you're moving, or other things like that. You'll see that in the demo as well. Then you can form a loop. So you can either have the robot move from one side all the way to the end and then turn around and come back through the path, or have it loop around by connecting them. And so we'll do both of those things. This is an example of when you're on a goal, you highlight it and you can set the speed or do some other little operations that become active at that goal. Okay, so this is a set the speed. I already mentioned most of these things. You could do a custom script as well, and that's kind of cool because that's where you can put your own magic in there. Like you want the robot to do something or other once it gets to this point. So you stop, you do your thing, and then it continues on the route after that. An example would be you're moving between tables and you want people to stick stuff on the robot or whatever, or you're bringing them something and then they tell it to go once it's delivered to them. Other actions in progress too. So once you go into the route, you enter the name and typical things. This is pretty boring here, but basically the idea is you can later load these maps and load particular routes, which can be different for a given map. So that's kind of nice if you want to do a couple of different things in the same workspace. I said I have a video. I'm hoping I won't have to use the video. That's the backup demo plan. So anyway, we have an N301 LS LiDAR, and it looks kind of nice. It's a 360-degree LiDAR. They come in different flavors. We just are using the, I think it's a 10-meter one, 360 degrees. And then Lama localization. I'm thinking I'm going to probably switch to demo, and we'll get back to this one later. So I'm going to do a stop share on this. And I'm going to get this screen out of the way. And now we're going to go to live demo. Does anybody want to ask anything briefly? We don't want to like try to explain the whole thing, but I'll take a few questions if the slide presentation didn't seem clear.
So is this GUI in lieu of RViz?
Oh yeah, this is okay. So this is actually a web application, and you bring it up on Chrome, or we've brought it up on Safari and Chrome, and we can't guarantee every browser because I don't think anybody in the world can do that. But we do have Chrome and some other ones that you can bring it up on. And so we don't have to worry about some kind of custom software running. You know, it's going to run on your PC, or I've run it on my Chromebook, run it on a tablet, that sort of thing.
How does the data go from the ROS thingy to your browser?
So as it turns out, this app in the screen is being served from the Magni robot. So we are integrating our, with JavaScript and other stuff, we are talking to ROS and reading the topics and you know, setting command vel and doing basically doing everything through ROS and then using this as a screen. So this is a web app. FiddlerBot had a web app a million years ago, but it's nothing as pretty as this. So anyway.
How much is that? How much is that LiDAR?
Yeah, so it's a decent LiDAR. It's expensive. It's like many hundreds of dollars, like $600–700. Okay, so we're working to try to get a discount from them. We're also trying to qualify some other LiDARs. If you've looked at any of the pages I've made, I kind of like the RP LiDAR. So I've actually fired this up with my own RP LiDAR and just messed around with the URDF and so forth. And I've gotten this app and everything to run with an RP LiDAR. Okay, so the LiDAR is not, the only thing that's important about the LiDAR is it has to be 360 degrees. Okay, should we move on to the demo?
Onward, forward.
I'm waiting for something in case I dropped out. All right, let's see, there's this guy. Oh, no, that's the video. We don't want that. What do we want? Oh, we want this one here. Okay. All right, can people still hear me?
Yes.
Okay, you should
Affirmative.
You should see on the right-hand side a Chrome browser, and then on the upper left, a live video of the room next to me, which is the Magni blue guy sitting in the middle there. And so you basically, you go to the web page. Let's see, okay. And you get a little splash screen, and then it comes up in this mode that I've discussed. So you can move around and drive and stuff. This is like a live video feed of what the Raspberry Cam, which happens to be pointing kind of upwards, is seeing. We go over to the side here, and we hit Easy Map icon. And now, uh-oh, I left the door open. Hang on a second.
Live demos. Gotta love them.
We probably would have been okay, but anyway, yeah, now we're starting to see that wall show up there. But so you basically can move this around, and I'm using like mouse controls here to position the map, you know, and so forth. So it's reasonably intuitive. Now we have the robot. Here's the tank controls. So I'm going to drive forward a little bit, and we'll see that live in the upper left. And basically, I'm just going to let the map fill in a little bit more. You get a little bit more solid on the walls and so forth. So we'll back up now. And we haven't put in the algorithm yet that says, hey, if your robot in 1 millisecond moves 8 meters, ignore that. So anyway, okay, up.
Watch it.
I'll speed it up here. So, all right, so let's see, we'll just rotate around. Okay, so now we're going to define some goals. So basically, these are just double clicks. And as soon as I do that, I'm going to need a walkabout 1 is what I'll call this particular route. And once you've done that, you can double click and define waypoints, although we're calling them goals because they also have the ability to change, to define actions at a given goal. This is the tricky one. I got to make sure I don't get too close to the piano. All right. Okay, so here's the goals. Now I'm going to click and hold this and add an action. And so what I'll do is I'll set the speed here to a reasonable speed so it's not ripping around this room at blazing speed. And on this goal here, we'll have it like hang out for a few seconds or something. So we'll do a wait. We're gonna be doing things like wait until someone hits a switch, or possible verbal recognition, that sort of thing. But those are all just inserting different actions that have to be developed, of course. Okay, so we'll say we'll hang out for 4 seconds there, and then on this goal down here, I don't know if you see the cursor. Do you guys see the cursor?
Yes.
Affirmative. Yes.
Oh, great. Because otherwise, this would be hard to follow. Okay.
Is this on ROS? Is this on ROS 2?
No. And so, but we are definitely working on trying to get ROS 2, going and so forth. But we haven't done it. I'm still going to keep it a safe speed, but I'll make it visibly faster. So all of this, we are actively working on getting ROS 2 going, but that's a completely separate topic. Okay, so then we're going to go to here. Let's see. Okay, we'll slow it down again here, and then I'll just show you how this thing works. Okay, so I will go to like there. Okay, so now we've defined some goals or waypoints, if you will. And there's the robot. And so now we're going to play this route. So now you can watch in the upper left or in the right, and it uses by default the poses that you see as those arrows. You can also change the pose at a particular position or something if you want to. So we're moving around. Now it's gonna go to, this is the one that we told it to wait a while. Okay. So, you know, pretty basic little operation. So now it's gonna hang out for like, I think it was 4 seconds. And now we're gonna go to this next goal. And then at the next goal, I think we cranked up the speed. I should have given it a longer run, but see, you can see it's going faster. By default, what it does is it turns around, and if I hit play here, it would turn around and go back the other way. Oh, I don't want that. Okay. So what I'm going to do though is I'm going to show you another cool little mode that you can use here. Let's see, we'll go like this. I got it going intentionally kind of slow so I don't smash into anything. I do have, by the way, oh, wow. I just did something really bad. Okay, I better get this pose right. I just accidentally activated the thing to set the pose. So fortunately, I may have gotten away with that. We'll see. I might have destroyed the accuracy a little bit. Anyway, what I'm going to do is I'm going to define another waypoint, and then I'm going to bring that over and connect it. So now we have a route that is a closed route. So therefore, it would, you know, circle around and keep going till the batteries ran out, right, Camp? Okay, so we'll let it. Yes. Anybody?
Affirmative. Hey, is this AMCL?
No. So this is Llama. So they have localization, SLAM. It's like a completely different thing. So, but there's a web page and a link, and we're going to get to that slide right after it finishes this, by the way. We are, in fact, we are like working with the guy that has done this, because we did not develop this SLAM, okay? And you've already mentioned, but Enrico Pedrosa, and he's of Intelligent Robotics and Systems Lab. And what we've done is also asked him to utilize a fiducial-based system for ceiling or on the wall fiducials, or even on the ground. And therefore, this system is meant to work with multiple modes of sensors. You don't have to use LiDAR, right? Okay, so I'm going to stop that over in the right here. There's a going down the fast route. Okay. Let's see, this I think is stop. And then we'll go back. I'm going to show you that Llama thing. Okay, my video shows me that I really did stop. Yay, that's important. There you go.
Woo, awesome.
You didn't smash the piano either. That's great.
Smash the piano either, yeah. Okay, Let's see. Now I'm going to unshare this and I'm going to go back to the slideshow. By the way, Camp was really nice enough to let us dry lab this because believe me, there were a couple of hiccups. So we're going to go in and do
My pleasure.
Another share. Okay, make that guy big. There's slim. All right. PowerPoint, that thingy. Okay, here we go. We're going to now share the slide thing. So hopefully that's present again.
Yes.
Affirmative.
Let's see. Okay. So I have a link here. Gosh, it would be nice if I could actually post that, but I don't think yes, I can. Yay. No, it's in some kind of editing mode. All right. I have to post that over on the comment channel. And this is the writer, Eurico Pedrosa. And then it's a stack that you can read about various modes that it has. And it's actually pretty interesting. It's got some particle filter stuff going on. It's got some other localization modes that we don't specifically use, but it's really quite a project. So it's very interesting. Okay, then to summarize, we have this web interface, so you don't have to have any kind of custom hardware to run this. That's served off of the Magni. And then we define a map and have it saved. We define routes. You can have multiple routes, so you can put, and a route includes all those goals and actions. And I mean, it includes the goals, how they're connected up, where they're positioned, all that stuff, and what you want to do at each goal. So you can make it do different things within your workspace, whatever. Okay, then it's got some other diagnostic stuff and the video feeds and all that we've just shown. Okay, so I guess that is it.
I posted that link for you.
Yeah, thanks. Because I should have realized that would have been handy to put in there. Okay, I'm gonna.
Dumb question. You have to create a topic for your battery level, right?
Yeah, so that's actually a Magni. We have a large number of topics, but one of them is battery state. And so, yeah, a lot of this is relying on the topics and things that are available in our image. If you pulled our image and loaded it and so forth, and then made changes to support, like I've got a couple robots that are not Magnis that are running on the Ubiquity Robotics image, and I know other people do as well. So if you did those things and supported them, like in order to run battery state, you'd actually have to somehow get, that would be hard to support because that our main board reads, it reads the battery in a specific way. It's a part of our motor node. But other stuff, is pretty normal ROS stuff. So, okay, I'm going to stop this share. And if someone had some question that's on a slide, I'll just pull it back again. This concludes. Thank you very much. I now return you to our standard programming unless other questions.
So the URDF, is it the same thing that you would create for RViz?
Yeah. Yes and no. So we have a bunch of conditional stuff in our URDF. So we can place the camera at different locations, the LiDAR at different locations and stuff like that. So it's a kind of it's an involved URDF. It is on our GitHub and it's under the Magni_robot repository, but it's a really involved URDF. But it is, in fact, the same way it would be used on a standard ROS robot. Is like if you brought up a nav stack and you'd have to know the position of the LiDAR relative to base link, and you'd have to know all those things, where the wheels are, all that stuff. And that is in our URDF, just like it would be in any number of my other robots or your robots or anybody. So that's long-winded, but yes, it's a regular URDF in BASIC. So.
Tell us what's going on at Ubiquity these days.
So we have some other things besides this that are pretty cool. And one of them now actually shows up on a web page. So because it's on a web page, I can tell you about it. But we have like this disinfectant sprayer thing that is made by a company called Avalon Steratech. Okay. And they're calling it Moonstar. And it's a whole navigating, disinfecting system thing. It looks really nice. So they did the chassis. We did the internal electronic nodes and wheels and software and so forth. So that's pretty cool. The other thing is even more exciting, but I should have asked David if I could talk about it. So we're making this other platform that in short is based on fiducials that are on the ground. Okay. So that's kind of cool. And you can do a lot of things with that, you know, for whatever, any kind of application where you can stick things on the stick these stickers on the ground and program all the actions. And so kind of like what you just saw, but it's a different mechanism of doing it. There you've got physical waypoints sitting on the ground and so forth. That's very exciting. I'm really crossing my fingers on that one. That's all
I've seen a demo of that, and it is really cool. I hope we can get permission to see it. It's really cool.
Yep. I can't show you it now, but because it would give away too much weird stuff. But it's really neat. And this ground-based fiducial thing was, we looked at all the ceiling fiducials and all the challenges there, and people putting ceiling fiducials up. It's hard to do, right? You know, it takes a certain category of customer. So this was a couple of years ago, and I think Wayne was in those meetings, that we basically realized, why don't we stick some fiducials on the ground? Now, this is not new. Other people do this, right? But besides putting them on the ground, develop a system and a methodology to work with them that gives you an easy to use product that's actually usable in the industry and not just a toy. So that's cool. And that's about it.
Any more questions? Mark, thank you very much. That was an excellent presentation and a very interesting topic. It'll be interesting to see where this goes.
You know what I forgot to ask is, did anybody actually record this?
Yeah.
Oh, nice.
Chris Mayer.
I got to get that later. Thank you, Chris. Thank you.
Being recorded. Thank you very much.
Thank you. Thank you.
All right. Well, here we come to the random access portion of the meeting where we just chit chat amongst ourselves until security comes and kicks us out.
Don't everyone talk at once.
Yeah, I know. Actually, I have an interesting question which has nothing to do with robots. Is Shiloh over there with you, Dave, or is she still on the East Coast? I forgot what she said.
East Coast.
Okay, so that's a little bit later. All right. Rohan is back in the area, by the way. So that's cool. And a bunch of you know him, and that's why I mentioned it. It's robot news of a sort.
So has Rohan completed his degree?
No.
Okay. It's in Illinois, right?
Yeah.
Yeah, I think Rohan's about half done, right?
Something like
that. Yeah, he's halfway through.
All right, well, I'm going to mention one other thing since it's so quiet. I'm really excited out at JLC PCB. I'm making a Raspberry Pi Pico based sonar subsystem that talks over serial. I'm really psyched about that. And so that will appear on one of my robots. The Pico is kind of neat. You know, it's a dual core, reasonably powerful little system that instead of an Arduino, you can say, well, I want to take it up a notch. And so you can do that. Anyway, that's using traditional sonars, and I got the board. The board will only, let's see, the board has 6 sonars on it, but you can support more than that because there's quite a few IO pins on a Pico.
So was that a sonar Pico what?
Okay, hold on. So the other robot related news that is part of what I just said, which has nothing to do with the sonar thing, is the little $5 Pico. It's like this little Raspberry Pi based on the 2040, and it's got pin mounting, or you could surface mount it with those kind of pads like the ESP32 has and so forth. There's no Wi-Fi. So we're talking sort of bare metal stuff. We're not talking OS. Well, we're not talking GUI OS type stuff. We're talking, you can run real-time stuff on it, but in short, they have a dev system. You can download it, and so you can look for Raspberry Pi Pico, and it's a handy little step up from an Arduino for a comparable price.
Hey, Cam, Mark.
Yeah.
So Arduino has its own version now too that you can buy.
Oh, you know what? I was I guess being the straight man for you. I forgot to mention that. And they've put the ESP32-ish Wi-Fi on there, and then they have their own thing. Yes, I just heard about that. Thank you for bringing that up. I forgot to mention that. That's
it's a little more expensive. I think it's like. I think it was 25 through Amazon.
What exactly is that, Michael?
That's Arduino's version of the Pico.
It's when you got a 2040 processor, and then they also have a Wi-Fi module that's based off of the ESP32 core. But you don't actually see the ESP32. Instead, you've just got this Wi-Fi interface. The big chip in the center that he's showing is the 2040. It's a pretty large surface mount square, package. Thank you.
But you would still run Raspbian on it?
No. Yeah. See, they got their whole dev system and everything, and so if you looked up. It comes from the Raspberry Pi people, but there are actually a lot of flavors of 2040 processor boards, a lot. So I'm just talking about the one that comes directly from Raspberry Pi. You can get them on Adafruit.
I mean, when I think of Pi, I think of an OS.
I know.
Versus
that's
Arduino.
This is much closer to a bare metal. This is like Arduino Plus, right?
Okay.
No OS.
It's
okay.
You can run it in the IDE for Arduino. I'm running it with source code, and there's a way to do that too. But they have some of their own custom ways that their own API for calling GPIOs and all that. So it's not a Raspberry Pi, and it's not an Arduino. It's just somewhere in between.
Is it using the Arduino programming language?
So you can, I think you can, I believe they said they supported it in the Arduino IDE, which means, that would mean yes. I haven't used it like that yet.
It's an ARM Cortex M0, so it could run MicroPython, right, Mark?
MicroPython!
Yeah, get excited now.
I did that for Dave. You actually, by the way, they do tout that as the alternate OS or the alternate language. So yes, you run C-ish or Arduino or MicroPython. There is a distribution of that runs on this.
I've started programming my Arduinos with VS Code. Aren't you impressed?
I'm just writing it down because I don't know what it is.
That's what is that, Mike Wimble? That's Visual Studio. It's a Microsoft thing.
It's an IDE.
There you go.
Programmers. Everybody should use Visual Studio.
There we go.
Well, our friend Kevin says that some people will do Qt Create.
Yeah.
Yeah, there's always crazies in any group.
Wait. Let's not, anyway.
Friends don't let friends run Windows. That's,
No. So we go multi-platform. We go multi-platform.
Yes.
Yeah, Windows.
Because now Microsoft develops for ARM processor as well.
Visual Studio runs on a whole lot of stuff.
Well, not Studio Code.
This is VS Code. It's different.
Just VS Code.
It's also, I believe, open source.
It's based on the Atom.
Affirmative.
It's based on Node and Atom. So it's basically a UI framework that is IDE type of Chrome. And Microsoft came in, revamped it, and bolted the VS Code on it. And so,
I'd like to chime in on that too.
Yeah, go ahead.
So I'd like to say that I use VS Code on the NVIDIA products, and you can also run notebooks in there, so you can step through Python code if it is your desire to do any machine learning stuff with Python and libraries that are written in C++, but you can still step through the code one line at a time and debug it. And so that's a pretty neat feature of the VS Code and notebooks, conglomeration, I guess.
Dan Alberts, ladies and gentlemen.
Hey! Yes. And as long as I have the microphone.
We need a demo.
You need a demo? Oh, boy. And as long as I'm on it, I did get voice working on my NX for my robot by using Pico Voice. I don't know if anybody's ever used it before, but it's really great for audio processing. It's small. It runs on about 20 different platforms. And if you just want to add a command language, a command wake up, and then a, like, hey Siri kind of command, or hey my robot. And then and you can, obviously change the model, you can reprogram it, and you can run 20, 30 different commands, and it just kind of works. So I kind of recommend Pico Voice if anybody wants a low resource,
thank you,
speech recognition command thing.
Sounds like a good. Thank you.
Hey, Chris, while I'm thinking about it, make sure you save the chat. I don't seem to have a save chat option.
Yes, it saves it automatically, and I'm giving the chat text files to Al, who is posting them, and I believe he's going to put links to the chat on the YouTube description.
I don't see Brother Al with us today. He's doing a hell of a job on that website. Dr. Ed, you're out in Hawaii, aren't you? Give us a weather report from Hawaii. Dr. Ed's not talking. I see Gertz out there. Speak up, Gertz.
It's about 60% humidity and about 82 degrees. Partly cloudy, wind from the north-northwest. And it's going to be a beautiful night to look at the full moon.
It's still daylight out there, isn't it?
Yeah, in fact, it's only 5:30. We're about ready to go to dinner.
It worked out, huh?
Indeed.
Gertz, speak up.
Yeah, Camp, that's actually slightly humorous what you just said, but I'd
Hmm.
love to hear from Gertz as well. Man of few words.
Speak up.
Important.
Yeah.
All the words are
Hey.
important.
Hey, what's up?
Yay!
There he is. How you doing, buddy?
Good.
All right.
Look at him. He's got a propeller on it. He's a real propeller head.
There you go.
Yep.
There you go.
That fits. How's life, Gertz?
Good.
It's all right?
Life is good.
All right. Good deal. What you building these days?
Playing with Paul on some robots.
Excellent. Excellent. Grabbing things, of course.
Oh, I thought he said Les Paul. I thought he's taking up guitar.
Saki Robotics, which is Paul's name spelled backwards.
Saki. Yeah.
Very good. Well, one of these days, I say, we'll have to get together physically again, but I guess I'm kind of out of the loop there. I'll have to make a trip.
Yeah, Florida's fully
Did
vaccinated
you
now,
come
right?
back for the robots on ice? That was fun last year. I guess it
That was fun.
last year.
Now, Robots on Ice is coming up again. What did he say? December 11th or something?
Yeah, December 11th.
Somebody's going to have to head that up, Dee Dee.
Well, I'm definitely planning to attend. With the humanoids, of course.
That was an amazing event. I mean, it was like Maker Faire and Robo Games, but different because it was on ice. The funniest thing was I had Rocky out there spinning around counterclockwise, and I went over to run the Barbie bot and skate her around a little bit, and all of a sudden, out of the corner of my eye, I could see Rocky just drifting off to the left. And I'm like, holy cow, I thought one of the kids had grabbed my transmitter. And I looked over there, and the transmitter's just sitting on the bench. And on ground, the robot stays put and spins. But on ice, there was some kind of centrifugal force that it was just gliding over to the left. Fortunately, it didn't hit anybody. But I mean, it's like, whoa, funniest thing.
But we know you can't blame the in moves for doing that because they don't even have arms. So
They have biceps.
In move on ice. You need to. I could see an in move out there doing the ice skating thing. That would be very nice.
I know. I think he'd probably be messing around with the remote controls while people's backs are turned.
It's a lot of fun. So that's that. And that ice is slippery. I tell you what, you can hurt yourself out there.
You know what I think would be fun is have a flat bottom saucer and have a bunch of fans and do localization and moving around with the fans, because you got this problem on that is like inertia and no friction. So you're kind of like asteroids on ice, right?
There we go. Careful you don't end up with your asteroid on ice.
Yeah.
No, it was like, what was it? I don't know. My robot was in a particular place and I needed to step out to deal with it. And I took 1 and 2 steps, and coming from Florida, we don't have a lot of experience on the ice. And I realized, wow, this is slippery. And so, I kind of held up my hand to somebody and said, help me back out of here. But anyways, it was good. It was fun. Robots on Ice, that's in December. Who's that running it? Foot. What's his first name? Tully Foot?
Tully.
Yeah, I have to ping him. We have to get somebody to head it up for the HBRC. Somebody needs to head up the extracurricular activities in the HBRC. I'll be putting that in an email sometime soon.
Okay, I'm going to sign out. My dinner's getting ready. So take care, everybody. Enjoy.
Mark Johnson, thank you very much.
Stay healthy, everybody.
Great presentation.
Thank you.
Take care. Bye.
Yes. You headed out, Dee Dee? Was that a so long?
Hey, Camp, what is the Robots on Ice and what do I have to do to join?
Robot on at the HBRC mailing list, Tully Foote posted that they're going to do Robots on Ice again, and this is around December the 10th or so. I don't know the exact date, but it's on the mailing list. And let me see, just reminisce here a bit. I'll find the photos that we did last year.
Yeah, do you know offhand if there's any limitations as to what type of robot is on the ice?
No limitation.
Is it a competition or a demonstration?
It's a demo. Yeah, it's a demo thing, and it's just for fun. Actually, we set up some booths out there, so not all the robots were on ice necessarily, but like I say, it was interesting to put the robots on ice.
Yeah, Dan, I think self-driving cars and Karen, you don't want to fall through the ice.
Well, there you go.
Is this an ice rink or is this over a pond?
This is an ice rink. It's an ice rink.
but even so, it
Yeah.
has a maximum
I think I could probably by December get my quadruped to move on ice. I mean, how hard can it be, right?
Yeah.
Don't answer that. Nick Donaldson brought out his giant mega spider, and it was very awesome. Here it comes. Robots on ice. Let me share my screen.
It just sounds great because it's just enough time that I can postpone and push off the actual work for another 2 months and still get it done.
You can still do it at the last minute. There's plenty of time to do it at the last minute. Roboticists are the worst procrastinators. So this is Robots on Ice 2020. Here's Nick Donaldson with the giant spider.
Ooh.
There we are, Dee Dee. And Dee Dee, what's your daughter's name? Lauren? Something like that.
Oh, you are still there?
What's going on?
Is this pandemic or
They set us up. What's that?
Is this pre-pandemic?
Just before, exactly. This is December, like middle of December in 2020.
No, actually January 6th or something.
Was it? Okay.
Yeah.
They had like an Olympic ice skater out there.
Is there any like robotic hackathons?
Got to get over the pandemic. I think we're getting there. And we had some talk at the business meeting about, physically meeting, and, we'll talk about it. I think it might be a good idea to try and do SIGs first. And the problem is going to be where to meet, of course. Google's still at least a year out. There's Marco. Rocky and the crazy guy. Barbie bot. Here's Tully. There's our own Wayne Gramlich. Good times. I'll have to send Nick an email, let him know. Get him to resurrect the giant spider.
Where was this event?
San Jose. Gosh, it's a shopping center. San Jose. I don't recall the exact location. Is Grit?
My old coworker went to this. He brought his rover style robot. Taylor Alexander.
Yeah, those are Taylor's robots. Who's speaking? Who is this?
Oren.
Oren. Okay. Yeah, Taylor brought the. He had a one of those rocker boogie steering robots. So there they are out on the ice. Good times. This is where Rocky was like spinning in counterclockwise, and all of a sudden he's drifting off to the left. It's funny. That doesn't happen on pavement. I guess the wheel just kind of unlocked and it was sliding off to the left and hit the gate there. Good times. So here's Nick. Now he's got a monkey that pops out of that hat every now and then. Cheeky monkey.
Yeah, it looks like that was in Sunnyvale.
Yeah.
Oh, good. Thank you.
At least based on the signs that are on the sides there.
Sunnyvale, yes.
Yeah.
Not sure if I remember correctly, but I think the city of Sunnyvale does an ice rink, and this was sort of the advertising.
There's Taylor, right?
Yay.
Is that Taylor?
Yes, it is.
Mm-hmm.
He had a really cool talk at my computer science club about the gears he made. It's really cool 3D printed gear stuff. I don't know if he's talked at this club before.
Well, he's got a book about total world domination or something, isn't it? Where everybody has their own 3D printers and they're making their own stuff and whatnot.
I wouldn't doubt it.
Yeah, he's a real rebel, rebel with a cause. All right, folks, what else is going on? I've got some stuff to do. I need to move along. This has been a lot of fun. This has been good. We do a ROS discussion every Tuesday evening. We've got the HBRC business meeting on first Wednesday. That will be June the 7th, where we discuss HBRC business. Any and everybody's invited. And of course, the SIG, the special interest group, is for the folks that one meeting a month is not enough. That's on the penultimate Wednesdays. And of course, the general meeting is the ultimate Wednesday. And in June, this will be our 19th annual HBRC Challenge Phase 2. So you are responsible for the presentation. Show us what you're building. Thank you very much. And Chris, are you still out there? Chris Mayer?
Yeah, I'm going to officially end the meeting and stop the recording. However, I'll leave the meeting going for people to chat for the next hour.
All right. Very good. Thank you, everybody, for coming out.